Hey, hello there. Yeah, Alex from Blue Lightning Software. Just wanted to finish up on these example that I've been doing to show burst compiled job system code utilizing SIMD, optimized single instruction multiple data. That's what burst is doing really. What I was also looking at is IL2CPP interaction with burst, and I wanted to compare to, the argument is that these are some results for different things. This is GCCs, this is GNU compiled C++ versus burst CLang compiled. This is just straightforward mono unity C#. That kind of looks, that Fibonacci, that looks similar to stuff years ago. Early 2000 or something. I used to, well, I still do, I guess, to an extent, program kind of options price stuff, mostly for myself, my own purpose now. But if you've ever typed in option pricing libraries, that kind of thing, it's this kind of math, Fibonacci's, I think, makes sense. And I used to find, when this was really early on .NET, 2004, I remember looking at this kind of thing, and just comparing. Oh, it's my C++ versus C#. Dog. There's a dog walking past. It goes crazy. That's my dog. But yeah, no, I used to find that C++, I had a loose ratio in my mind. It wasn't quite double. It was about, I used to find, if you wrote the same code, okay, in a C++ .NET compiler, wrote it unmanaged, compiled it up, and ran that over massive iterations, a large number of iterations, just to get a time trial, I used to find about 1.5, this was my loose mental benchmark I had at the time, was that C++ would be 1.5 times faster, or C# rather would run, take 1.5 times as long as C++ compiled. It was about that difference. So if you took C++ unmanaged and you took C# managed, back then it was about 1.5 times. That was a loose thing I had in my head for this kind of stuff. Fibonacci numbers. Don't even know what that is. Don't know. But look, this comparing burst GCC. So this saying what C language and GCC. IL2CPP. I always felt was intermediate language 2CPP, which is kind of Unity compiling mono to be C++. You can see something. I don't know why there's no number there. It's very similar to burst sometimes. These are kind of in line though. That kind of like, if that's just straight C# Unity in mono, and that's burst, that's GCC. You can see this 1.5 times thing. C++ green to C# pink. You can see that difference. It's kind of the radix, I don't know, and burst is always comparable. IL2CP is very comparable to C++, just compiling to IL2CPP. You're not very far different, except in some things. I don't know why there's no Fibonacci thing there. I misunderstood it. Radix, whatever that is. Can you see, just IL2CPP gets you very close, and then burst. So this is like burst without the threading. I've not rigged up a test for that particular purpose. What I was finding is about, I'm not going to be testing. My test obviously has burst threaded, multi-threaded. These would probably all be the same. There's not magic C++ threading, or, it's like Windows thread pool ultimately underneath it. There's no magic threading language, I don't think. So that would be all pretty similar. And the difficulty is what I wanted to show. It's not so useful because all that we're doing is IL2CPP. If I compile burst stuff to IL2CPP, reading this highlight piece here, IL2CPP operates at arm's length with burst. It does this by calling burst compile code very similarly to how it calls any other native code via pinvoke. So it calls into it like a native library, and it's not that bad. Don't worry about it. I don't think IL2CPP could possibly slow down burst. I don't know. This kind of stuff, though, this is what I'm seeing with the difference between C# mono, because the difficulty is the test I've rigged up at the moment is like not threaded. So this should be like tasks versus burst would make a lot more sense, which I don't have. I won't go back. It's about 10 times for that, but that's not what this is showing. This is showing just a massive difference. Certain tasks, single precision math, double precision math, huge difference between single precision math and double precision math. What was this? Integer math. I didn't do my stuff in integer. I used to work almost wholly in doubles, so I would have seen this 1.5 here. This is probably what I've tested previously. I would say between the green and the pink, I've found it yeah, well, let's read the top of this page to actually see this. Benchmarks. Hold on, it's in there somewhere. Where does he say it? There's somewhere. Here we go. C# code. C code compiled with all possible optimizations. So he's kind of burstified. What I'm saying is burst is mostly utilizing SIMD stuff, single instruction, multiple data. So he's using like a SIMD accelerated numeric type kind of thing, optimization type optimization within C++. That's how he's made C++ GCC comparable to burst. Actually slightly better in a lot of cases. But having used all possible optimizations, so burst itself and GCC are kind of like a mega, same with C-lang when he uses that, are kind of like mega optimized C or C++ or burst. That's what he's saying. That's why it's quite a lot different. Double precision. That's more than twice as fast as this. What gets me though, the vectors. I mean, it's not just the threading. Oh my gosh, what's this? The threading is what's doing it. So what I did is I built it. Now, right now it's built with. This doesn't actually reveal much because the difference is IL2CPP. Is that better? Cancel now, don't worry. Alright. Yeah, anyway, I built this one. That's been built already. I've got the output here. Another screen, let's find it. Here we go. So, build IL2CPP. Let's give it 1,000 cubes. You can type this in now. 10,000 and 10,000 cubes. You have to press this. Creates cubes. Press jobs. 6 milliseconds, and 30 milliseconds. This is compiled 309. So that's IL2CPP compiled. I think it's actually capable of doing 100,000 cubes. It takes a while to build those. Jobs can move those 36 milliseconds, cool, 106 total work. It's take ages. This is shifting 100,000 cubes. 3.1 seconds. That's with IL2CPP. So let's go in and build it without IL2CPP. Let's go mono. It just saves, right? Also, I'm just checking that I don't miss it. Mono. Okay, that's done. So we're going to build we're going to go to this one, and we're going to build so this is now just mono, and I think hopefully I can just leave that open. They got the same name, so it's going to be confusing. Remember, on the left is IL2CPP, compiled nothing. It's not really comparable unless I did tasks. IL2CPP would affect the tasks. It's multi-threaded, so you would get multi-threaded IL2CPP, which would be the more comparable number, because this is massively parallel threaded. Definitely it is parallel threaded. Burst. But anyway, this would indicate. What's up with that? Here we go. This would indicate. Do 10,000. Just check it's working. Yeah, this will indicate if what does IL2CPP on the left do, if anything, to the job system. 10,000 jobs. I don't. Does that exist? 93, 98. Yeah. Do you know what? No, that's all over the place. That number is totally comparable. That's totally comparable, isn't it? I don't think you can say those numbers are incomparable. I mean, I'm trying to say no. Look, I mean, that's IL2CPP calling burst. That would actually, look, do you know what is definitely different? Jobs took 50 milliseconds. There's a longer call. No, there isn't. No, I'm talking rubbish. I don't think you can say there's any difference. It's kind of like randomized. These sometimes have a lower call number. I would say, if anything, all I could really say is that the time for completion is about the same, but these IL2CPP ones seem to call the time it takes to make the calls is usually quicker, possibly because it's IL2CPP, the call structure, yeah, the code surrounding the jobs. Just a point. Let's look at nothing. Wow, what? Is that right? I may have to go back to the drawing board for this. What's happened? That doesn't make sense. I've got my cubes. A stack of cubes. Yeah, no, this makes sense. This is waiting for nothing to calculate for 3 seconds without this IL2CPP. Oh wow, can you see the difference there? That's IL2CPP, 3189 milliseconds. That's raw mono. Okay, now that's comparable to the IL2CPP to burst number. The yellow is on the left and pink is on the right. So it looks kind of like that, doesn't it? Yeah, we're kind of showing that's true. That's IL2CPP compiled. That's a good attempt at getting just a C++ compile out of Unity with a garbage collection added to that somehow. So we can replicate that, but without the threading, we're not getting this. Well, threading's at least a factor of 10, which isn't shown here. It might take me a while to get the threads back up on these. I'll just see if I could do it in a minute and not do it, but see, I deleted all the old task code. barely remember off the top of my head. What's nothing doing? Test nothing, test task, task method, task run complex. Yeah, that would do it. There's nothing method then. Nothing test complex, yeah. So what task finished? Jobs finished, task finished. Okay, so I've got that. Where's that called from? Task method, where's that called from? Task test. I've still got a task test. Okay, I could probably do this. So rather than that button there, we would go to here. And yeah, let's just comment it out. That we can go back to the task test and maybe compile that. Do you know what I saw with these? I think if I set up a thread pool myself, I don't think it makes a lot of difference how you do it. In terms of the speed I was seeing between tasks and jobs being threaded, it seemed about the same. You can say, oh, the way it's calling threads and stuff, but they look pretty similar to me. Maybe I'm wrong. In terms of performance, so nothing now means tasks. Just check it works. Oh my god, I forgot you. So not error handled. This is why the XEs are just might blow up. You got to. I didn't have a default. Maybe I should just input the default numbers. Never mind. Cubes. Nothing is now tasks. Doing it with tasks. Get position cannot be called from the. Oh wow, sorry about that. Yeah, because of all the transform stuff, it's not going to work. That was a waste of time, wasn't it? Whoops. Yes, threading tasks. That's the interesting point, isn't it? The threaded task would now have to look more like the job, because it's just going to manipulate the vector and bring it back. Yeah, I'm a bit too worn out to do that now, but that's interesting. It'd be great just to show the difference. Threaded. If you give me 5 minutes, I might come back with a second video that will look at that, but possibly not. But that's some of the interesting things between the differences between the two.